Question 3. It is known that under the standard treatment for a certain disease, 9.7% of patients with the disease experience side effects within 1 year. In a trial of a new treatment, a random sample of 450 patients with this disease was selected and the number X who experienced side effects within 1 year was noted. The first question, state one assumption needed in order to use a binomial model for X. I think the confusion with this question is a lot of people went to just stating the reasons we would use a binomial model. But the difference here is we're asked to state one assumption that's needed. So we don't just list one out of the 4 conditions we need. A number of people just put fixed number of trials. Well, we're not really assuming that there is a fixed number of trials. We know that there was a fixed number of 450 patients in our sample. So what we need to do is think about some of our other conditions. For example, the fact that there is a fixed probability. That's what we need for our binomial model. But in terms of the context of the question, it's really important that we have the context here. We want to write something along the lines of the probability of side effects is the same for each patient. Okay, that's saying fixed probability, but doing it in context. You could have also had other, so just reading from the mark scheme, you could have also had the patients are independent, or you could also have patients from random sample of the population. Okay, but I'd say that's probably what I've highlighted there. It's probably the most common answer to this question. Part B then, it was found that 51 of the 450 patients experienced side effects within 1 year. Test at the 10% significance level with the proportion of patients experienced side effects within 1 year is greater under the new treatment than under the standard treatment. Firstly, we need to define what P is. So we're going to write our hypotheses in a second. We'll write down P. Most of the time, you just can write P. The mark scheme did say that you needed to define what P was. So you need to find what your probability actually is. So I'll put here, let P be the proportion of patients experiencing side effects. I was lenient when I marked this, but I will say that this was in the mark scheme, that you did need this for the first mark. So we write down our hypotheses. And the null hypothesis is that the probability will remain, or the proportion will remain at 0.097. The alternative hypothesis is because whether the proportion of patients experience side effects within 1 year is greater, we are going to look at the probability being greater than 0.097. We also know that this is going to be binomially distributed, with n being 450 because there's 450 in our sample, and we've got this fixed probability of 0.097. So it's found in the sample 51 patients experienced a side effect. So what we want to do is we want to test whether the probability that you find 51 or more patients in the sample is greater than or less than our significance level. Remember, if you have greater than here, you will have greater than or equal to here. Well, when you are doing a hypothesis test with a binomial distribution, that's a one-tailed test. Okay, so just make sure that you've got the correct notation. Some people put greater than here, but then less than or equal to here. So if we want to find the probability that x is greater than or equal to 51, we need to do 1 minus the probability of 50 or less. So we can just do that on our calculator. So I just bring up my calculator, binomial CD here. So I've got more than one value. I'll do 50 or less. So I put x as 50 and then put n as 450, and then the probability is 0.097. This gives me 0.862 to 3 significant figures. So the probability in a sample of 450, the probability that 51 or more experience side effects is going to be 0.138. So now what I have to do is just simply compare that to my significance level. It's a one-tailed test, so I don't need to half it. That probability is greater than my significance level. So when that's the case, I accept the null hypothesis. And I would state that there is insufficient evidence to suggest the proportion of patients. I'm just pretty much taking the claim from the question. So if you're ever not sure what to write for your conclusion, just look at what the claim originally was. It's important though we do include words such as the patient's side effects, getting that context in, and also using the word greater than, greater there. So not change, because change would imply a two-tailed test, but greater because we're just talking about a one-tailed test here.